Hello everyone, and welcome to our Week 7 video lecture. This will be a rather short video because I will not discuss any new topics, but mainly just go over the Week 7 assignment. It's all about working with pandas, and we already discussed pandas last week, so I will jump right into the Week 7 assignment. We only have one assignment this week, and it's just in Python, so there is no R assignment for this week. And this Python assignment is asking us to work with data from the provided Excel file, which is down here at the bottom. So please download it, and we will need to import the data from this file. And here's the file opened, and you can see we have 7 columns, starting with record, then product, diameter in feet, depth in feet, cubic feet, dryer, and warranty. And if we quickly skim over the file, you will find some NA values. And you also find some duplicates, like here and here. But instead of doing this review effort manually, we will use Python code to take care of all these manual steps. Then the instructions are asking us to get information about the dataset. So if you remember from last week, we would use the info method, which is part of the pandas data frame. Then we need to change all the column names to lower letters, because as you can see in the Excel sheet, some letters are in caps, so we need to change everything to all lowercase letters. Okay, let's go back to the assignment instructions. Next, we need to remove all the duplicates. Then any reference of NA values, these need to be replaced with blank values, and then make these blank values populated with the mean value of the particular column. Then we need to add a new column to our data frame and call it standard bushels. And we see that the calculation formula has been provided for us already, which is to multiply the cubic feet value by 0.80385. And once we do all that, then we need to export this changed data frame to a new Excel file called binsdatacleaned.xlsx. Then I need to get some statistical data on my data frame, but not include data for the record column. So I will need to drop my record column from my current data frame, then get the statistical data on it, then export this data to a new Excel file called binscontinuous.xlsx. And for my next instruction, I need to focus on the product column and get the total count for each value in the product column. So if you go back to our original Excel file, under the product column, we have repeated values like elite, premium, intermediate, and basic. We now need to find the total for each of these values individually. For example, how many are basic, how many are elite, and so on. Okay, let's go back to our assignment for the last set of instructions. We will now do some filtering on our data. The instructions are asking us to find only certain records that match several criteria. For example, it wants us to find only elite products with a diameter of over 25 feet and with standard bushels of 42,000 or less. Also with dryers, and also have an extended warranty. So we need to come up with a filtering syntax to meet all these criteria. And whatever records are returned, we will put this result in a new data frame and call it bins selected. Then export this new data frame to a new Excel file called binsselected.xlsx. So all this needs to be done in one Python code file, which you need to submit along with the 3 Excel files that your code will export. So please submit one Python code file along with the binsdataclean Excel file, the binscontinuous Excel file, and the binsselected Excel file. And last but not least, please create a Loom video that explains your code and the output when you run it. Now, if you can't work with videos, then as an alternative, please create a Word document and include a detailed explanation of your code along with the different screenshots. Okay, I'll now go to my version of the solution code to demonstrate how all these instructions can be written in Python and run them successfully. Alright, first things first. Please remember to always comment your code because this is part of best programming practices. Single line comments can just use the single pound sign, but for multiple line comments, I use the triple single quotes. So the first line of code is to import the Pandas library because we will be using it to create our data frame and working with our data. And as usual, I like to alias my library names to make typing less. Now I didn't need to say that the Pandas library needs to be first installed because we already installed it for last week's assignment. But in case this was the first time working with Pandas, make sure that you install it using the pip install command. Alright, next line of code is to import the data from the original Excel file into a Pandas data frame. And I do this via the read_excel method of my Pandas object. And I pass it two arguments. The file that has my data, and since it's an Excel file, which can have multiple sheets, I will specify which sheet to use in my second argument. Then I need to display some basic information about my code. So I call the info method of my Pandas data frame. And I follow it with a simple print statement to add a few blank lines to make my output easier on the eye to read. Next, I have to change all my column headers to lowercase characters. I first added a print statement to output the current column headers as is. Then I make the change. Then I print them out again to see how they changed. And for my change statement between the two print statements, I'm basically setting the columns of my bins data frame using a loop statement. But first, we see that they are surrounded by brackets because the bins.columns object returns a list of column names. So lists use brackets. Then in my for loop expression, I have call as my iteration variable, which will iterate in the bins data frame and apply the lower method on each call variable in each iteration. So this will take each column header and change the letters all to lower letters. Next, I need to remove any duplicate rows. So we have seen earlier that we have duplicated rows in our original Excel file, and now it's time to remove them using Pandas code. But I added a before and after behavior. I will print out the shape of my data frame before I remove duplicates to see what the data frame looks like. Then I'll print the shape again after the change has been made. So the shape method just returns a tuple that contains the number of records and the number of columns. As for removing duplicates, I call the drop_duplicates method on my Pandas data frame, and it magically takes care of that problem, removing the duplicates. Very easy, right? And you can see in my comments that the number of rows went from 306 to 300. But we will also see it in action when I run this code. Next, I need to replace any NA values with blank values. So I call the fill NA method on my bins data frame, and that's all I have to do to fix my NA problem. And now that I have blank cells, I want to fill them with some value. And per the assignment's instructions, I need to replace them with the mean value of the columns. So when I reviewed my data before, I saw that NA values were found in two columns, diameter in feet and depth in feet. So I need to set these columns blank values with new values, which I do by calling the fill NA method again on these two columns only. Alright, in the next block of code, I added a new column, and the syntax for that is to call the data frame by its name, and in the square brackets, give it a name of a column that doesn't yet exist. I then assign it a value, and in this particular case, it's the product of 0.80385 and the cubic feet value from the bins data frame. And I also round that to 0 decimal points. Then I do a printout of the info method to see if my newly added column is actually here or not, and as always, I like to give it some space between my outputs with a print statement of 3 blank lines. Finally, I export all the updated data in my bins data frame to an Excel file called bins data cleaned with a sheet called data, and I don't include the index column because I already have a column for indexing, which is called record. Actually, for my next block of code, I need to create a new data frame, but this time without the record column. So I'm going to create a new data frame called temp, and it is equal to the current bins data frame. Then I'll call the drop method of my temp data frame and pass it the name of my column, which in this case is record. So now the temp data frame is a copy of the bins data frame minus the record column. Next, I need to get statistical data on my temp data frame, so I call the describe method, and round all the values to 2 decimal points. Then I assign this updated data frame into a new data frame called bins continuous. Next, I need to export this new bins continuous data frame to an Excel file called binscontinuous.xlsx with a sheet name called data. And before moving on to my next block of code, I will delete the temporary temp data frame as I no longer need it. The next code block is where I display the count for each of my product values. So I print out a statement that says the product column count, followed by my syntax, which is the product column of the bins data frame. And here I call the value underscore counts method, followed by a few lines of space. So it's this value underscore counts method that will do the magic for us and display a total count for each value of items in our product column. Then the remaining lines of code is all about filtering our data. I'm interested in just the elite bin products that have a diameter of over 25 and standard bushels of less than or equal to 42,000, and also have dryers and extended warranty. So the way I chose to do it is to create a new data frame called elite bins. That first just equals the elite products. Then I update this elite bins data frame to only include diameter in feet that's larger than 25 and standard bushels of less than or equal to 42,000 and dryer value equals to yes and warranty value equals to extended. And once this data frame has been filtered with this data, then I'll export the newly updated data to an Excel file called bin selected. So that's pretty much the code for this assignment, and that's how I chose to do it. Now the moment of truth is upon us. Will this code run successfully or not? Well, let's run this code and see what we get back. Alright, good news is no errors. So first let's review the outputs we get in our screen. We get information about our first original data frame, which has the full 306 records and only 7 columns, which is correct. Next, I see the column names in their original format, which is upper and lowercase letters. Then just below that, I see the column headers all in lowercase letters. Then I see the shape of the current data frame before I drop the duplicates, which first is at 306 records and 7 columns. Then the drop duplicates method is run, and then the updated output is now 300 records and still 7 columns. So it looks like there were 6 duplicated records in our original data. Good to know. Then next in our output, we see the info method run again, but this time we see the updated 300 records only. Plus we see the standard bushels column has been added for a total of 8 columns. And the last set of output we see here is the count for the different values in the product column. So we see that we have 123 premium count, while elite has 73 count, basic is 71, and intermediate is 33. So that wraps up the console output, and now let me show you the 3 exported Excel files. First, this is the bins data cleaned file. You can see the NA values are no longer found, and now they have been replaced with mean values. And here we used to have a duplicated record, and now it's removed. And also the total number of record has been reduced to 300 due to the removal of these duplicates. And here's our bins continuous Excel file, which has just the statistical data. So we see the count, the mean, the standard deviation, and also min, max, and the percentage quartiles. And last but not least, we have the bins selected Excel file, which just has records for the filtered data. So we only have these records because they match all the criteria we specified in our Python code, which were only the elite products with a diameter larger than 25, with a dryer and extended warranty, and also standard bushels of less than 42,000. So that's pretty much it for our assignment this week, and please remember to create a video explaining your work, the code, and the outputs. Also, please don't forget to submit the Python file and the 3 Excel files. Alright, I hope this was helpful, and please let me know if you have any questions. Thank you for watching, take care, and bye for now.